Good evening, or afternoon, or morning if you're in Australia. Welcome to the BS and Beer Show. I'm Travis Brungart, and I have a small construction company in Kansas City. Tonight, I am drinking, as Dan Edelman already spied, the Society and Solitude number 4, which is pretty tasty and was a gift from Dan, so of course he noted it. Tonight, we're talking about the wondrous world of Windows. We want to first introduce the fact that this is a BS and Beer show, so the drinking's encouraged, and so are the BS and Beer discussion groups that this sprung out of. Of course, the BS stands for Building Science. If you guys need information about how to start your own BS and Beer discussion group, there are links for that at thebsandbeershow.com, and of course, reach out to us. We'd be happy to help you with that. We want to, of course, recognize and thank our wonderful partners, Green Building Advisor and Fine Home Building. With that, I'm going to introduce Brian Pontalillo, who will go over how this show works.
Hey, everyone. I am Brian Pontalillo from Fine Home Building and Green Building Advisor. I am drinking ginger turmeric tea tonight. Like I just said, I'd really like to be drinking coffee, and I went over to the coffee station thinking I was going to go for it, and at the last minute I said, don't do it, and I made tea instead. So it's tea for me this evening. So the show is going to work as it usually does tonight for the most part. Where we'll introduce our panelists, and tonight the one thing that'll be a little bit different is I'm going to give the introductory presentation, just sort of an introduction to choosing Windows to sort of set a baseline for a discussion that will probably be pretty high level with the crew that we have on the show tonight. So hopefully I'll do that as efficiently as possible. And after that, we'll get into a discussion between us, the hosts, and our panelists. We'll be watching the chat box all night long to pull out your questions to ask of any particular panelist or host. So please jot your questions down in there. We'll all be watching. And if you have a real pressing question, keep writing it in there, because sometimes we miss them. It's hard to keep up with the chat as we watch the show. And I'm gonna, as I pass the show over to Emily for the introductions, I'm gonna launch a poll, just a quick one question poll tonight. We're just trying to learn more about who's attending and how things that you're interested in and how you're kind of consuming this show. So if you look for that and maybe just take a second to make one choice, we'd appreciate it. And with that, here comes the poll, and here comes Emily.
Hi guys, Emily Mottram. I'm an architect up here in Maine. Mottram Architecture and the E3 podcast, if you haven't tuned in there, had some great continued conversations from BS and Beer with some BS and Beer guests. So this week, Doug Horgan's going to be on the podcast, so make sure you tune in. I have the pleasure of introducing guests tonight, but first I want to say I am having probably my all-time favorite Maine beer company lunch tonight. This is a great beer. If you're an IPA fan, Maine Beer Company makes some really awesome beers. So big plug for them there. Also, last week we launched the idea of the BS and Beer Show book club. So that's now live on the bsandbeershow.com. The first post is up about what the book is. We're going to do the new Carbon Architecture by Bruce King. We're going to do that for the next couple of months. So it's going to be a quarterly book, because I realize we're all busy. Nobody has time. So we picked a smaller book for summer reading that should be easy to get through. I had a hard time putting it down after chapter 1 and deciding to go to work. So if you want to join us on the book club, the book is up and a link to where you can buy it if you don't already own it. And so now I get to launch into our guests for tonight. And so I'm going to start with you, Steve. Steve Constantino is the founder and owner of Performance Building Supply. He's an expert in building science and renewable energy systems. Steve designed and built 2 passive solar homes himself, often struggling to find healthy building materials and information. So he now provides those types of products and information to a community of like-minded developers, architects, contractors, and homeowners up here in Maine. And I'd venture to say that Steve is a parent of the BS and Beer Show concept because he started the building science discussion group about 10 years ago in Portland, Maine. So it has been a pleasure. So Steve, I'm going to ask you to introduce what you're drinking, anything else you'd like to tell us about yourself. And I'm supposed to ask you a question about windows because that's what we're going to talk about tonight. So anything you want to say about windows? I know you're a European triple pane guy. So my question is, what's the difference between European triple pane and US triple pane? Okay. Short answer.
Thanks, Emily. Yeah, that's a long answer. I have a fresh cut from Peak Organic, local organic beer. Anyway, I'm Steve. Thank you for the introduction, Emily. Windows are such an important part of a wall system. I'm not going to dive right into the difference between all these different types of windows because that's a pretty long conversation. But if you look at the R value of a 2x6 and then look at the R value of most windows, you start to see that if you can get a window that outperforms a 2x6, you make a big difference in a wall all around. So I'll say that.
Awesome.
More glass.
More glass.
Less framing.
More glass, less framing. Then you don't have enough insulation, Steve. We'll come back to that.
Oh, we got to have the insulation, just no framing. Yeah.
All right, Russell, you're up next. Russell has built a career around various sales positions supporting the construction industry. Currently, he is an architectural consultant for Sierra Pacific Windows, where he works directly with architectural design community to help them best meet their clients' expectations and goals. Russ is married with 2 boys and lives in Putney, Vermont. When he is not geeking out over fenestration, he enjoys skiing, kayaking, and gardening. So tell us a little bit more about yourself, what you're drinking, and what's the most underappreciated aspect of window design.
Thank you, Emily. I am drinking my very last home brew that I whipped up in March, just as soon as this whole thing happened. And it was a porter, it was a coffee porter, but I've since aptly named it Pandemic Porter. So this is the very last Pandemic Porter. And you can't see it, but it's good. On that note, I guess I'll just follow up and say, you know, I've been a big fan of these building science groups for a really long time. I actually lived in Montana for a number of years, and in 2007 or 2008, I've got to give a big shout out to the Southwest Montana Building and Industry Association for having a green builders group. And maybe there was about 3 of us that showed up initially, but there was probably about a dozen or 15 by the time I stopped going in 2011. And coming back east, I was very excited to learn what Steve and others were up to in Maine. And I was very honored and very grateful for the opportunity to you guys are getting a 2 weeks in a row of the SEON group, the Sustainable Energy Outreach Network from Southern Vermont here. Last week, Peter and Dave, the Wingnuts, were an offshoot of that, or certainly are valued members of that group. And I was a member of that group as well. So totally stealing Steve's ideas and implementing them in southeastern Vermont. It's worked out really well. What was your question on Windows again? I'm sorry.
No, that's okay. Just anything you want to say about Windows. But the question was, what's the most underappreciated aspect of window design?
I think a lot of people underestimate how many options they have, how many choices they really have in the marketplace. No disrespect to all of my builder friends out there, but I think it gets to become really easy to kind of just railroad your clients into making certain decisions without sitting down and discussing the goals that they have for their project with them. It's really easy to just gravitate towards what you use because that's what you use, but that isn't always the right answer for your client, and every client's a little different. So I think it's important to really sit down and know your client and know what their goals are in order to best meet them, whatever, in all aspects of the trade.
Awesome. And Joe Nichols is the general manager of Thrive Building Solutions, which provides consulting and product solutions for high performance and passive house buildings. Joe represents Aero Barrier, Alpine Windows and Doors, EPS structural insulated panels, and Zender ERVs. He believes in homes that are healthy, durable, comfortable, and are provided through integrity, consistency, and accountability. Positive collaborative communication is the core of his business, and he provides direct service and support in all aspects of his work. And so that we don't get dinged about only doing Northeast people, he's not in the Northeast for everyone joining in. So what's unique about the windows that you use? Introduce your beer, tell us a little bit more about yourself and Thrive Building.
Yeah, sure. Thank you, Emily, for that introduction. Tonight I'm drinking Martin City Brewing Company's here. I guess technically in Martin City, just a southern suburb of Kansas City. The Easy Way IPA is kind of their session IPA. They also have, my favorite beer is probably the Hard Way IPA, which is a little more of an imperial feel. I thought if I was going to have a few of these, I should probably go with the session while I'm on camera. So that was tonight's choice. Thrive Building Solutions. We're really excited to do the work we do here in Kansas City. You kind of listed a bit of a grab bag of different products that we work with. And essentially in our market, we're a builder's resource for builders that are trying to move forward on the types of homes they build, specifically on the envelope. So if they're trying to find a product they can't get their hands on, we rep that product, we get that product in front of builders, and we're really trying to move the market and create more of a social movement here around Passive House. My background's as a project manager, builder called Prairie Design Build here, one of I think the only Passive House builder here in Kansas City, a couple others that are sniffing it. And then Travis and I started the local KC BS and Beer. So thankful to be here with Travis as always. I guess what I love about windows, I feel like most of the components of the envelope, a lot of the things you just mentioned, the other products we represent, you're either burying them underground, you're hiding them in a closet, or you're covering them with something else. You know, there's no other components of the envelope that really stay front and center all the way through the build. And when the house is finished, they're still kind of there in all their glory. And so for me, windows kind of connect those dots from, you know, the performance of the envelope as well as having the aesthetics that we look for in finish on these really beautiful homes. So I think that makes them unique, and that's what I really like about them. Excited to be here today and talk a bit more.
All right, Travis, if you're going to do your toast, it's up to you. If you're passing, it's on to Brian.
Oh, that toast is hot garbage. Everybody raise your glasses and drink to good health, and let's get Brian started telling us about windows. Cheers.
All right, let me share my screen here. So are you all seeing that PowerPoint? Yeah?
Looking good, Brian.
All right. So there's a couple things that you're gonna learn from this presentation tonight, which is an introduction to choosing windows. The first thing you're going to learn is that I don't know all that much about windows, which maybe makes me a great candidate to give sort of a baseline presentation. But totally will be interested to hear any feedback on some of the things that I present tonight, because I really drew from a whole bunch of sources, from researched articles, work that I've done in the building media world, and just everything from comments that I hear from people, questions that we get on GBA. I kind of pulled from everywhere, so I'll be interested to hear your feedback. Another thing that you're going to learn tonight is how much I like the design options that PowerPoint offers. I used a whole bunch of them in this presentation. So with that, here we go. Introduction to choosing windows. We'll start just looking at the basic types of window operation and just narrow it down to a few of the sort of the primary types. The first one is double hungs. Double hungs are sort of the quintessential window. I think they're maybe the most traditional in appearance, maybe the window that's been kind of around the longest and is on our oldest homes, and it tends to be an enduring style, and it's a pretty flexible style because you have varieties in light patterns and and some other features that allow them to fit into both traditional homes where we're used to seeing them to even some more modern spaces. They have a nice slim profile, and by that I mean they stay within the window frame. And as you'll see when we talk about some other window types that don't stay within the window frame, what the advantages are there. Double hungs neither take up floor space nor project outside the building. Double hungs can open both from the bottom and from the top, and people like that for a few different reasons. Some people think that it allows for the best ventilation. Some people like to keep the bottom closed to keep rain out and let the top down a little bit, maybe even some security issues there. Unfortunately, by nature, a double hung can only open half of the window. Even if you have both the sashes open, you're still covering half of the window. They might be the most affordable. They also might be the most challenging for some people to operate because you have to be able to lift them. You have to be able to physically move them. They tend to be the most drafty, though that is something that might be challenged, and there's testing to answer those questions anyway. And they have exterior screens, which is an aesthetic benefit for some people. And just to note here, there are also single hungs where the top sash doesn't actually move. And sliders, horizontal sliders, tend to have similar pros and cons to double hungs. The next most common American window particularly, is going to be a casement. Casements tend to crank out. So they have a cranking mechanism, and that's how you open them with the handle, and they move outside of the building. There's lots of style options in casements. In fact, I've seen some casements that are now made to mimic double hungs so that you can have the operation of a casement, the look of a double hung, and they look pretty convincing. So there's a lot of style options, but they tend to be a little bit more modern in look. You can open the full window. That's a pro for a lot of people. The interior screens are a con for a lot of people. That tends to be more present in a casement window, that screen is right there. They tend to be a step up in cost from double hungs. They can be a little bit tighter. A lot of that has to do with the locking mechanism. And unfortunately, they project outside of the building, which can raise durability issues. And they also have a couple of, they're different windows, but awning windows and hopper windows they operate very similar to casements. Awning windows being hinged at the top so that they swing out from the bottom. Hopper windows open from the top and just tilt down a little bit, both opening outside of the building. And then we're going to go to tilt turn windows, and this is the way that a lot of the high performance European windows that you may see in high performance homes operate. So they have two modes of opening. They can tilt in from the top, and that's a kind of a ventilation option. So the window's not open that much, but you still get good ventilation. Or they can open in swing, so swing inward, and they can open, if the walls allow them to, they can open all the way. As Emily pointed out to me this week when we were chatting about windows, often in homes with thick walls, high performance homes, you might limit that opening based on where you put your window in the opening. You might not be able to get it open past 90 degrees. They're said to have, and these are generalizations, of course, but they're known for having great locking mechanisms, both a benefit for security and for air sealing. Some people note that they're super easy to clean. Some people complain that they don't stay open. I'm sure there's a solution to that, but a lot of feedback on GBA about how wind and pressure and depressurization of the home tend to move the sash when the homeowners would prefer that it didn't. They do require interior space to open, so you can't have furniture in front of them if you want them to open, and you have to kind of plan for that. And they have these wide, kind of clunky frames. That has a lot to do with why they can be so high performance, but there's also an aesthetic thing there, and maybe minimizing the actual glazing if you're looking for a lot of clear glass. And they may be the most expensive window, at least the ones that we're seeing used in high performance homes. Because they're high performance windows, they tend to be on the higher end of the cost spectrum. So of all of these windows, you have two kind of common installation types. And I think this is an important decision when we're building with new products and we're building trickier assemblies. I think we have to consider what type of installation either we are most comfortable with if we're doing the work ourselves, or maybe the builder that we're working with is the most comfortable with. If they've, for example, never installed a flangeless or inset window, they might not feel as comfortable with those details, and that may drive the decision-making process a little bit. Essentially, you have, and there's lots of variations on window installations, of course, but for wood-framed walls, essentially you have flanged or nail fin windows where that flange is pressed against the sheathing or a window buck, and that is how the window is fastened in place. There's lots of variety on those flanges. Some are better than others. Fully welded flanges tend to be a little bit more robust, and builders tend to be a little bit more confident in them than flanges that aren't even attached to the window when you get the window, or are folded down and you have to really work the corners to make them weatherproof. And then there's the flangeless or European windows. They are set within the opening, and maybe they're a little bit trickier to flash. Maybe the flashing details are just a little less known to American builders. That might depend on who you ask, maybe, to answer that question. But there's a couple of benefits. You do get to set this window wherever you would like it in the rough opening. So you could push it all the way out to the plane of the sheathing. You could pull it all the way towards the interior, or you can place it somewhere in the middle. And they tend to attach to the framing with clips. So they come with some clips that are let into the frame, and then those clips are screwed to the house framing. And then, as you can see in this photo, if you're looking at the screen, they often have these pre-drilled holes through the frames, and screws are provided to fasten the windows to the framing. This window, Jake Bruton was installing this window when I took this photo, and he noted that with this company, Shuco windows, you get these particular screws, which are called turbo screws, with operable windows. You don't get them with inoperable windows. And I guess the idea is that with these windows are very rigid anyway, and with inoperable windows, there's not so much force being put on the frames, and you don't necessarily need these screws. The clips are sufficient. So you do need to think about how a window installs when you're making a product choice. And by the way, none of this this is all information that you need to choose a window, not necessarily in the order that you would think about these things as you're choosing windows. And that's a question maybe I can ask when I'm done with this, is about the process of choosing windows and where you prioritize the decision-making process. So we'll look quickly at window performance and how to compare it. And I'm going to run with the National Fenestration Rating Council label as sort of the way we're going to look at this. And while you can get this information probably from the manufacturer's website or the manufacturer's catalogs or from your lumber yard, this sticker has there's some specificity to how the ratings are on this sticker that are worth paying attention to. So you can do helpful kind of quick comparisons with this. This sticker and these particular ratings are also what the International Residential Code Council looks at. NFRC writes the performance ratings. It's NFRC 100 and 200 for the big important ratings. And then the testing is done in independent labs. So it's not done by the manufacturers and reported, but it's done in independent labs for them to get this label. And then the labels become sort of your proof to your building official that the windows meet code. So you leave the labels on the windows for inspection. And if you don't have the label and the building inspector is being picky about your windows, they'll look in the IRC, and in the IRC there's data that will be assigned to your windows based on what the building inspector can glean from looking at it on site. So the first thing we'll look at is the U factor. U factor is maybe the big one in a lot of climates, the big rating that you'll want to pay attention to. And for people who are used to R value as the guide or the sort of the data point for thermal performance, this can be a tricky one because you don't find U factor on many products, but you will always find it on the windows. So R value is going to be a measure of a material's resistance to heat flow, so how it slows heat flow. And U factor is just the opposite of that. It's how much heat the material actually conducts. So it's mathematically it's the inverse of R value. So if you're not good at math, you can just try to remember that while R factor, a better, I'm sorry, R value, a better R value is a higher number, a better U value is a lower number. So you're looking for the lowest number possible here. And this is going to be important in pretty much all climates. In a high performance home, you're going to want to go for the best thermal performance you can get. And one of the reasons why this looking at the U factor from the NFRC is so important is because you can be sure that it's whole window performance. So you could measure U factor of the glazing, you could measure U factor of the frame, and you could get two different numbers. So this, the U factor listed on the label is the whole window U factor. So that's the best number to know, better than one particular center of glazing U factor or the frame U factor. Yes. Moving on, we'll just quickly show you these are the listed U factor ratings for the different climate zones of the US. I didn't put a map up, but climate zone 1 is the warmest climate zone in the US, climate zone 8 the coldest. So in climate zone 1, there's no requirement, and that goes all the way up to a or down to a U factor of 0.30 required in our cold climate zones. Not that we want to base our purchasing decisions on the IRC. Maybe we want even better performance than this. Probably we do. Definitely we do in a high performance home, but this is a starting point. The solar heat gain coefficient similarly is a whole window solar heat gain coefficient when you find it on this label. It's always a number between 0 and 1. And this is a measure of the solar energy that will radiate through a window. So let's say you had a window that was always going to be shaded. It was never going to see direct sunlight. This would be a less significant data performance criteria for your window. And just the opposite, a window that's always going to get sunlight, this is going to become, maybe move to the top of the list as your performance criteria. So the lower the number is, the less solar energy passes. The less solar energy passes, the less surfaces and other materials in your house get warmed, and the less they emit that heat. So this is going to keep this is going to help keep your, especially a warm climate home, it's going to help keep it cooler. And this is a more nuanced decision than U factor. And the reason for that, to really simplify it, is that in a hot climate with a lot of sunlight, you're definitely going to want to keep as much solar energy out of the house as possible. In a colder climate, you might be designing a high performance house and you might be relying on sunlight to warm the house. That might be part of your energy modeling. You might not want as high of a solar heat gain coefficient. Only the warm climate zones require, in the IRC, require a specific solar heat gain coefficient, and here's a quick look at what they are. Moving on to air leakage, this is a voluntary rating. Even though this seems like a very important rating, this is a voluntary rating on this label. Again, in this case, the lower number, the less air leakage is going to have. And it's a measurement of cubic feet per minute per square foot of the window area. And it's tested with, and it tests that simulates a 25-mile-an-hour wind. And it's tested on new windows too. And I think that's interesting because weather stripping certainly is something that is going to wear over time. And I'd be, for one, would be curious to see what it would be like to test windows that had been in, that maybe had really high, or again, really low ratings in when they were new, and see what they were, how they were performing when they had been in service for a few years. The IRC, Energy Star, and really the industry standard is going to be 0.3 or less for air leakage. Visible transmittance, another scale, this time 0 to 1 scale, and it's a measure of how much visible light gets through a window. Obviously, this is something you want to think about because windows, one of the most important things that windows do is light the inside of our house when the sun's out. And another important thing they do is they give us views that are really important to our mental health and our emotional health. And so the better job a window does of this, the happier we're going to be with our window performance. So a high visible transmittance rating is going to be desirable, and this can have an aesthetic effect. This is another thing that Emily and I were discussing. I asked if she ever uses different window ratings, maybe different solar heat gain coefficient on different parts of the house, maybe in the wintertime wanting, more solar energy getting in the house on the south side, and maybe wanting a different rating for the north side or the east and the west sides of the house. And one of the things she pointed out is that windows, as the technology that gets us to these performance criteria that make windows perform the way they do, change the color of the glass. And maybe you wouldn't notice that when you were looking at just a window. You might not notice that how much light is not getting through, or how much your view is obstructed looking at one window or multiple windows that are the same. But when you put two different windows in one space, and often in homes these days we have these open floor plans, they tend to look different. So the only reason I ever came across to want less visible light transmittance was to maybe reduce glare. But when I was reading about that, the article that I was reading it in actually didn't give an example of when that would be, and I couldn't actually come up with one. So maybe that's something else that someone has an opinion on, if they've ever used less visible light transmittance to reduce glare. An interesting thing about visible transmittance too, and maybe someone else knows about this, but I found visible transmittance listed in the IRC. It basically says, going back to what I mentioned before, it says that if you don't have this sticker on your window, the inspector is going to assign your window a visible transmittance value. However, I couldn't find anywhere in the IRC that specifies what that value needs to be. So it seemed like an odd mention of this rating. And then finally, we have the condensation resistance. This again is a voluntary standard, so this may not be on all NFRC labels. This can be a bigger number. It's a 1 to 100 scale. The lower number, the less likely your window is to accumulate condensation on the interior surface. And really how this test is done is through a dew point calculation. So I think they're looking at whole window U factors and solar heat gain coefficients, and they're taking an outdoor temperature of 0 degrees and 3 different indoor relative humidity levels, and determining through a dew point temperature calculation of the interior surface whether that interior glass will ever reach the dew point temperature where there's the potential for condensation. Okay, so just a couple of notes about European labels. Since the NFRC doesn't operate in Europe, if you get European windows and they have labels, they might not be NFRC labels. And so it's important to check up on a couple of things. For one thing, Europeans calculate U factor often calculate U factor differently than Americans do. As you see on if you're again looking at the screen here, you'll see on this sticker in the photo, it actually has both of the U factor ratings, the US and the European standard. Also, you may want to make sure that any other sticker that's not NFRC is actually listing whole window ratings. You want to make sure that you're okay with your building inspector. Sometimes these stickers, these labels also don't come on the windows. They might even come before the windows. Jake Rudin says he likes that as a way of, he takes the stickers out as he goes around and taking a look at his window order and inspecting the windows and making sure that everything's arrived. He just matches up the labels with the windows, and that's a nice way for him to work. But I just think it's important to know that these labels are going to be a little bit different, and it's worth making sure that you know what you're getting. So how do we get to these performance levels? Just going to throw out a few terms here. These terms maybe will come up in the discussion tonight. If they do, great. If they don't, that's okay too. Maybe this slide and one of the next slides don't matter as much. Once you've landed on performance ratings that you want, and you know that they're whole window performance ratings, maybe it doesn't matter how the window's made to you, and that becomes less significant. One term you might want to know is IGU, or insulated glazing unit. That's what you're seeing here. So we used to have, if everyone knows, windows used to be single pane, and then sometime, I think it was in the 50s, and I think it was Andersen Windows, welded 2 panes of glass together, and the IGU was born. They learned at some point thereafter to fill in between those 2 panes of glass with an inert gas. most commonly argon. It's an insulating gas and improved window performance greatly. The next step in that, the advancement of that technology was to add warm edge spacers. So those original IGUs had aluminum spacers. So aluminum, keeping the two panes of glass separated and creating the structure around the edges of the glazing unit. But aluminum's not a great insulator. So manufacturers have come up with foam, plastic, stainless steel, and other ways to take the aluminum out of there and to separate and construct these IGUs that are less conductive, and therefore increasing the performance of the window. Next thing that came along, I think I've got this in the right order. The next thing that came along was low E coatings. So these are metallic coatings that can be applied to any of the now they can be applied to any of the glazing surfaces. Originally, these coatings were soft and they were always applied to an interior surface. Now we have hard coatings that can be applied to exterior surfaces too. Low E coatings again increase performance of windows, and manufacturers can get really savvy with where they put those coatings on which panes of glass and which sides, and they can really dial in the performance of windows for specific climates. And then I think in response to So we had double pane windows, and they were performing really well. And then triple pane windows came along, which performed even better. One of the cons of triple pane windows is the weight, and manufacturers at some point developed suspended films, and you can see the suspended films in this IGU here. And I think it all started with the heat mirror technology. I think that was the first suspended film. But essentially, this is an additional. You can think of it as an additional pane of glazing put in the window, except that it is a polymer, maybe with a coating on it instead of a heavy piece of glass. So all of these things are what makes our windows perform as well as they do today. And then the last thing that to talk about here are the frame materials. And we could get into what frame materials are better from a performance perspective. Certainly some materials are going to conduct energy quicker than other materials. So some material, one material is going to have a higher R value, just a material itself, than another. Some can be insulated, others can't. All that said, again, if you've got the performance that you want, whole window performance that you're looking for, then I think frame material might become more of an aesthetic decision. So what you prefer style-wise, a maintenance decision. So how much maintenance you're willing to do on your windows, and then a durability, just a durability decision. Maybe if you like to open your windows and you have casements, maybe a wood sash isn't as good idea as something that's going to be a little bit more durable out in the weather, maybe getting hit by rain, maybe getting battered by wind. So I think that this often comes down to, the frame material often is going to come down to those decisions. And thank you. I think that's all I have.
Brian, that was exceptional. I've got it all now. I've had a lot of questions about Windows. I've got a few more, but I'm sure our panelists will come in and take care of that for me too. I think that's a great baseline to get us started in our discussion. There were a bunch of great comments and questions in the chat box as you were rolling through. I know I said I wasn't going to watch the chat box, but I got sucked in, as I always do with the chat box. So well, I guess I don't want to dominate. Why don't we get into our panelists right away? What did you guys think? You got any bones to pick with Brian after his presentation? Anyone want to get rowdy? No, everybody's smiling.
Look at them all being quiet. So
the polite group, yeah.
Yeah, I thought he did a great job. Like you, Travis, I hesitate to engage chat directly, but I think they're tough but fair. So if Steve and Russell have comments, I'd love to learn from those guys, or we can get right into the chat.
I think Steve actually has some visuals that he was going to use to talk about some things that he has experience with. So I'd love to hear from all three of you based on the windows that you have experience with, kind of what your offerings are. So Steve, if you want to go first, I'll bring up your slides to help illustrate some of your what you wanted to share. Let me start the. Can you all see that as a screen share, or are you seeing the slides too? It's good. Okay.
Thank you. Yeah. So there are, when you look at European windows, tilt-turn windows generally, the UPVC type is probably the highest performing window you're going to find in Europe or in the US. So the U values are very, very low, 0.12, 0.13, depending on the size and type of window. The glass is thick. The glazing unit is thick. So if you look at a typical North American triple pane, it is overall, it's just thinner than what they have out of Europe. It's almost a 2-inch thick insulated glazing unit. The glass itself starts at about 4 millimeters, goes to 6 millimeters, depending on the size of the unit. So you get less bowing on the glass itself under wind and pressure loads. So the spaces stay pretty solid in between the glazing. That has an effect overall too. So, and everything is triple gasketed and multi-point locks. One of the things I will mention, we'll get to
let me know when you want me to change the slides.
Yeah, so they also have aluminum, solid aluminum, wood with aluminum. They all operate the same way. There's different features to that. With the wood windows out of Europe, everything comes pre-finished. They pre-finish the wood before they assemble the unit. So all of the dovetail edges, all the corner grains, everything is sealed. You never have to finish a window on site. That just doesn't happen. This is a corner section of a Shuco Aluminum. Steve Basic did a whole thing on it recently, which was excellent, by the way. So same window. So we can go right past that. Watch Steve's thing. The wood and wood aluminum, you'll see the aluminum is actually a rain screen cladding on the wood. It's not directly on the wood. So it allows that wood to stay dry, keeps it from getting rotting as quick. When you put metal against wood, what you get a moisture trap and condensation. So all the European aluminum is all just vented so that the wood stays dry. Go ahead. So one of the things, I'm jumping ahead there. Okay, so one of the things Brian mentioned was about the operable, when you open a tilt window, if you open it and tilt, yes, it can move in the wind, but generally you're going to tilt it when you're not near the window. You tilt it to vent, it gets a lot of ventilation, there's a lot of airspace around that channel, but it keeps the weather out, keeps the wind from blowing papers off your desk, and keeps the rain outside. So they'll stay in place when they're in tilt. You could leave it there for indefinitely and it's perfectly safe. You tilt it open, it makes it, or you tilt it open, turn it open, makes it very easy to clean, replace the screen. And if you want to stand in that window, it's a full window at that point. Like he was pointing out with a double hung, you can only open it part way. So if you want to lean out the window, you have to bend over a bit. This, you can just be in the window, feel like you're, in the streets of Paris, waving at people down below. So go ahead. So also with the, you can use turbo screws if you're drilling through the frame. It's easier in some ways with an operable window to do that. With a fixed window, you have to pull the glass out if you're going to screw through the frame. So most people don't want to do that. Once you take glass out, you've got all these loose edges, much easier to break them. It's just more work and complications sometimes. So usually we'll have clips like this, which we're just showing basically you clip them on, you bend them in, bend them back, and they square off with your rough opening framing. Very easy to work with. It's definitely easier to go that route with a fixed window. And a lot of people, once they're doing that, they'll just use them on all so that they just get used to the same install pattern, even if it's operable. The turbo screws are very nice because they're threaded to the top and they're really rugged. So you can use an air shim in the rough opening to hold the window in place. Once you screw these screws in and get it all square and plumb, you can take the shims out and it'll stay right where it is. So you don't end up with any shims jammed into the rough opening. So when you go to foam it in or whatever you're doing for your infill, it fills the whole space. This is a profile. I'm going to thank Emily on this one. Thank you, Emily. So we worked on this recently. It's a little bit of rough format here, but basically I was trying to point out a very simple install when you go to the mid wall, or it's the same installation if you go all the way to the inside, where you're trying to create a pitch. You have a pitched clapboard and sill underneath. You flash it all in with tape, whatever, right to the inside of where the window is going to sit. This is a profile using an aluminum, looks like this, basically an aluminum sill that we can get with the windows, very thick gauge, not something you'd bend on site. It's very rugged. So the windows come with an extension profile underneath the sill, which gives you some height to tuck that sill underneath. And this is showing relatively easy detail. I like the details to stay simple because I have to go into the field and show people how to do stuff a lot. So if you get a complicated drawing detail, it's hard to teach people in the field and get them to do it right. So simple is better. So this is a profile, again, set into the window. They didn't want to use the aluminum sill on the outside, so they have a thicker piece of trim. It could be AZAC or Burrell or whatever. Similar process where you're putting a sloped sill underneath, dropping the window in, counter shimming it so it's flush, taping everything off, and then the sill is basically outside of your weather barrier. So all of my details are always trying to stay focused with keeping the weathering tape and whatever you're using in the same plane with the rest of the weather barrier, which usually is a wrap or something. So if you stay in that plane and consider all your siding a cladding and rain screen and keep it outside of that, then you're relatively safe on most of those details. This same kind of profile, except the windows pushed to the outside, which is a little more common. For most people in North America, you're going in the sheathing plane. This, you drop into the same plane as your sheathing and WRB. You flat tape it right into that opening, and then consider everything outside of it part of the cladding. This will usually require a little caulking joint right at the exterior extension sill. So that's the only spot you really end up having to need caulk. Not too complicated to do. People are very worried about not having a flange. So this is just showing a corner mulled wood aluminum window. You can see the detail can be very clean. This is a nice project up the coast. The photos aren't that great because the project's not done, but there's a lot of options with this. It's got a really clean finish. These are some photos from a project in Boston. You can see we can do pretty, you can do pretty big units with this as well. And structurally, they're very rugged. These were site mulled and still have, they're tall, so they have a lot of space and the structure's good. Oh. Self-promotion, there you go. The other big variation with these, there are multi-point locks on the windows as well as on any of the doors. And that's most of what I have right now.
Thanks, Steve.
Steve, what do you think? What do you think are the most important things that, not in terms of performance, in terms of workflow? What are the things that American builders who haven't worked with European windows need to know? For example, like lead time. Like, are there any other? What's the biggest learning curve in that, in terms of choosing, ordering, receiving a European window?
Yeah. So the order process usually involves shop drawings, so you have to plan that into your timeline a little bit. to approve all these window positions, make sure everything's accurate. Lead time, we get windows as quick as 8 weeks, but we usually plan on 12 weeks. So otherwise the flow is very good. They're loaded in a container in the factory. They're not touched again until they're in port in here and go to a warehouse. So they always arrive in good shape. I've never seen damage coming out of a container. They really strap them in there really well. So it takes a bit to unload a container. We don't deliver containers to a job site without sending a delivery crew. Some European windows you'll get, and they'll just ship the container to you, and then you have to figure out what to do to get it unloaded. So most of the time we're unloading in a warehouse in Massachusetts, and they're loaded onto a box truck and delivered to the site with a lift gate and a crew to unload. So it goes pretty smoothly. It's intimidating to get a whole container of windows if you've never done it before.
Brian, something I'll add from kind of the Midwest perspective. We usually see another 2 to at least 2 weeks on top of that. Now, I haven't ordered. I don't want to speak for Steve and for our European architectural supply, but we've worked with Clearwall and Glow and some other European manufacturers. So just speaking generally about that, we see really long lead times, and then we also have problems with service. You know, if we do get a unit that there's an issue with the glass, it's just a lead time. I shouldn't say problems. It's a challenge, certainly for us being in the Midwest. I think the East Coast probably does get a little better service. It's part of the reason that we work so closely with Alpen Windows out of Colorado. Just having, for one, it's American manufactured, so we don't have, nearly it's an 8-hour drive rather than a shipping container. So for us, and I think for some of the folks joining us on the West Coast and certainly in the mountains, it can be, Lindsay gets it. It can be a difficult process, I guess, to order from Europe. So just wanted to add that in there about Alpen. And I'm also curious, when ordering, Steve, and when you do have service issues, how do you guys deal with that? I'd love to learn more about your process with that.
Yeah, and I agree. I mean, we mostly work in the Northeast ourselves. We have done projects into the Midwest, but they usually have to be a big enough project. And we usually have the caveat is we're not just going to fly out there because you need a window adjustment. So some of that has to become teaching over the phone or documentation. But we go and service all of our projects in the Northeast. So if you break a piece of glass, we'll get more glass. We'll help install it. If the windows, when you're first putting them all in, if they're really out of adjustment, usually we'll show up or we'll talk to whoever to make it work. That project I showed you in Boston, I went down there and worked with the maintenance person for the building because it was 30 something units, and they wanted to know how everything worked and how to adjust. So we adjusted some together, and then he felt confident taking care of everything else, making sure it was going to work fine. But yeah, there's a lack of good documentation out there when you start looking, and there's a lack of support. I've talked to other people who supply windows that don't, European windows, and they don't understand actually how to adjust them and how they work. So we really try to get behind everything we do.
When you need to repair glass, is it the whole sash that gets replaced, or can you put a new glazing unit in the existing sash?
Oh yeah, you can pull glass right out. On the PVC windows particularly, it's very quick and easy to pull glazing stops. They're dry glazed, so you can pry off the glazing stops, pull the glass out, put the new glass in, snap the glazing beads back in. The aluminum clad on the outside actually comes off, and so they're glazed from the outside. But again, it's a dry glaze, so when you have to have a special little wrench to pull them off. But you can pull the aluminum off the outside, replace the glass. And the full aluminum windows still have a glazing bead as well. It's a slightly different process, but very quick and easy. And once you've done it, you're like, oh, this is pretty easy.
Is the lead time any quicker to get a new IGU
Yeah.
for a window?
Replacement glass, we usually have 6 to 8 weeks. Yeah.
Okay.
So, but the glass is heavy duty. It doesn't break very easy. We just did a 6-story multi-unit. They had a lot of windows, a lot of lift slide doors. They got everything done, and they broke one. It was like one of the last ones they put in. They broke one piece of glass. And usually when you break the glass, it's just you get a crack in one of the 3 panes. So you can install it and leave it there. It's, it'd be good long term, but it's a visual issue. So there's no urgency to replace it. It's not like the whole thing shatters and goes away.
Mm-hmm.
I want to add one more thing, if I could, Brian, on just kind of the lead times in your initial question. It's actually kind of a benefit with the European style windows because you do want to consider that commitment during the design process. I wouldn't recommend just taking an existing home and thinking, oh, let's put some European windows in here. That may work in some scenarios, but there's components like the in-swing feature can really affect use case on the inside if you're not thinking ahead. Certainly the lead time can be a challenge, but it's actually a benefit to have those discussions, I think earlier on in the design process, and to try to bring your builder and, if possible, bring your installer in on those discussions if it's the first time you're moving towards European style. I would say it's not difficult, it's just different. And so it's a lot more difficult if you get 2/3 of the way through it and you find out it's different than if you know it's different up front. So I think that's really critical. And one other thing I'll just mention quick while I'm talking is the door width. If you do have a swing door that's using a European style frame, your conventional sizing is different because you've got, typically, I don't know if every brand is like this, but typically you've got a full width frame. It's like a window frame with a swinging door in it. So if you're trying to get a 3.0 slab, you can't just spec, your normal 38 and whatever opening. You need like a 42-inch opening to get yourself a 3.0 slab. So I think the point I just want to reinforce is if you are moving, certainly work with, someone like Steve, myself, who can guide you in the design process, certainly an architect who understands what that means. And then the lead time kind of melts away as an issue.
Mm-hmm.
Those are all great points. I agree 100%.
Yeah, I
So-
agree there. I was going to say there's so much involved in that, and I want to actually give both of the other 2 gentlemen time to talk about the type of windows that they're most familiar with and talking about too. So we've talked about tilt and turn, but as Brian's presentation submitted, there are lots of different choices, and thank you for bringing up both the style choices, because sometimes it's not just a performance question. So I don't know if the 2 of you have visual presentations that you have as part of it as well, or if you want to kind of just jump in on what you're seeing in your market, in your area, and some of the other reasons why people make choices for windows. I have like 20 questions from the chat box, and starting with one of them actually that Russell wanted to answer, which was a question from Christoph about air leakage specs. So and there have been quite a few questions coming up in the chat box. Are double hungs the leakiest? Like, how are you doing? So I don't know if you want to talk about some of those things as well.
Well, thank you. I've been sitting here on my stool, just like just ready to jump. I really have. I've been ready to pounce. That was fantastic. And I want to start by saying thank you, Steve. Thank you. I for whatever it's worth, I truly am a huge fan of tilt turn windows. I absolutely love them. I always have. I think the intelligent design that goes into them is second to none. I drive a Volkswagen. Come on. It all fits. But that said, I think Emily did a good job of pivoting, and I'm going to totally take the ball down the field the other way. You don't have to go to Europe for great windows anymore. I personally attribute the European-US gap in performance to prioritizing what's important to consumers. And the United States has had cheap energy forever. We have not been forced to deal with things like they had to deal with in Europe after World War II, and having to conserve energy, having to build robust structures that are going to last in the absence of oil. That's not something we've ever had to even think about in this country, and I hope we never do. But the bottom line is, when you sit down to design a window in the United States, energy efficiency traditionally has not been at the top of the list of design features, whereas in Europe, it's been that way for a very long time. Triple glazing, frankly, was born out of the desire and the need to prevent condensation and actually rot in wood windows. That's a little known fact, but the Austrian government mandated triple glazing at one point in order to overcome an outbreak of mold in homes that had happened because of double glazing and condensation. So that was the precursor. Germany picked it up, ran with it, and made it really solid. And everybody in Europe today is benefiting from a lot of that research and technology that came about. That's all really great stuff. But when you're building a window in the United States, you're not dealing with the International Standards Organization and ISO testing. We're dealing with the NFRC. And we can argue about the merits of which program has a more real-world consequence. I'm not even going to tell you what my opinion is of that, because it doesn't really matter. But the bottom line is we're all bound by NFRC testing, and we have to engineer our windows around that. And as a result, you end up with an optimal airspace of a 1/2 inch in the United States per NFRC testing. That is 0 degrees Fahrenheit exterior, 70 degrees interior. When we're testing a product in Europe, we're generally using the ISO standards, and that's 32 degrees exterior, 70 degrees interior. That change in delta is the reason why you end up with a 5/8 optimal airspace from European windows that are tested to ISO standards. It's why you end up with much larger glass. There's definite truth in having larger glass equaling more efficiency. There are a number of US and Canadian manufacturers, not very many of us, but a few of us, and I will give credit to Sierra Pacific Windows shamelessly for being one of the best at that. If you can produce an insulated glass unit with 2 1/2 inch air spaces and sandwich that into a 2 1/4 thick sash or greater, you've created a really energy efficient casement or awning. Sierra Pacific Windows has NFRC rated casements and awnings as low as 0.14 and 0.15 U values, and that's unheard of. There is another manufacturer, to give credit where it's due, in the North America, that does a good job with this, but they're not quite there. Frankly, I think that's something to be considered. If we built that with 2 5/8 air spaces and tested it to ISO performance, I think it would stand up against tilt-turn windows. It'd be damn close, at least, with a wood-clad system. So it's really what it comes down to is knowing your client, knowing what's important to them. If at the top of your list is performance, hey, I won't disagree at all. Tilt-turn is a great place to start if that is your number one priority for you, for your client, or for yourself. If you want an authentic look, some people, I can't tell you how many times I see really nice projects come about and people want double hungs, and that's what they buy because that's what they grew up with. And it blows up an otherwise beautiful design. I also wonder, how the hell did you get a project along to construction documents with your client drawing a tilt-turn window when they don't want a tilt-turn window? I mean, there's something that you've got to have communication along the way, and I feel really bad for folks who have to experience that dilemma. Sorry,
an
Emily.
answer to that.
I see that look on your face.
They don't understand 2D drawings. They don't know what you're drawing. That's how you get to tilt-turn windows. And then you go in the end and you end up with double hungs. That's how you get them.
Makes sense, totally. So you opened a can of worms when you came to me, and I still haven't answered your original question. Now I'm going to get to that so that other folks have a chance to speak, and maybe I can catch a breath. But the original question was Christoph, and it was a brilliant question. He asked about the Pascal's rating with the testing of the windows. So that NFRC sticker that you're looking at on that window does not tell the entire story. You need to understand that there are 4 different classifications structures within our world of windows. And we have the residential standard, which is frankly not a very high performance standard at all. The next step up is your commercial window standard that you'll test to. light commercial windows, anything that you might see with a performance grade of LC 50, for instance. That's light commercial performance grade 50 PSFs. That's going to be for your threat for impact rating on a coastal application. You're not going to achieve coastal impact ratings with a window that's rated to R50. There isn't even an R50, it only goes to 30. But this moves up and it's a tiered structure. So the light commercial window spec, being the second, has a 75 Pascal rating for pressure. When you go up the next level, you go to the commercial window specification. That's 300 Pascals. It's 4 times the pressure. So when you see a window that's got a CW PG50 rating, you know that that's been tested at 4 times the pressure that an LC PG50 has been tested at. So that was an awesome question, Christoph. That is the difference, and you should key in on that. That's really, really important to understand. And you're not necessarily going to get that off the NFRC label. You oftentimes have to ask your manufacturer's rep or your distributor for a test report. On that note, I'm going to add also that 0.30. Brian, you did a great job with the presentation. Thank you. That NFRC label you showed with the 0.30 air leakage rating, many windows today carry, when you get that air leakage thing, you're going to see it says 0.30. It's a placeholder in a lot of cases. The information technology side of the business to try to associate values from a test report to an NFRC label is extremely difficult. And most manufacturers have not cracked that nut because, frankly, there's not enough pressure on them. Most people, unfortunately, don't look at air leakage that much and don't call and say, how come this number is 0.30? That's the maximum allowed. Reality is most of your double hung products today probably are half of the 0.30 standard. A lot of your casement products are in the for instance, Sierra Pacific's Aspen series with a 0.14 triple glazed U value also has a 0.01 CFM air leakage rate at 300 Pascals. It's a CWPG 65 window. So again, shamelessly plugging, but I hope that helps everybody understand. These are the criteria that we need to be looking at. And as per usual, we're paying attention to a lot of stuff that doesn't tell the whole story. And whenever we're having anybody put a label on our window, there's only so many boxes that can be filled. And that isn't necessarily telling everybody what they need to know. And I think these European guys would agree with that wholeheartedly, that when you start looking at the components of your windows and you start looking at the U values that goes into that, your frame, your sash components, your glazing components, spacers, that stuff is, the minutia really, really matters with windows. And too often that's not understood, and we just stick a bunch of glass in a hole and call it a day.
So Joe, you haven't said much, so weigh in.
I feel great. I'm really excited to get to some questions. I guess to kind of bridge the gap a little bit, my strongest experience is with Alpine High Performance Products, who does a European style tilt turn, not unlike the Shucos. And we also have a fiberglass line that is a more traditional US style in terms of operation, in terms of frame profile, in terms of all that. In the interest of time, I mean, I'd love to get to some of these great questions. I'll just direct everybody to thinkalpen.com, thinkalpen.com. All kinds of testing data. I totally agree with what Russ is saying. You have to understand why you're using the window in the first place. You have different requirements in different parts of the country and, commercial, residential, and we'll get into some of that, I think, with the questions. Something great that Alpen does while we're doing shameless plugs is we have an architectural design manual that's on the website. If you go to the website, up in the header, you'll see resources. Just click on that. You can see every spec sheet, all the testing data for all the units. You can see frame profiles. You can see, install details. You can see recommended tie-ins for all your different barriers in your build. So I'll just kind of direct everyone there, say, yep, we do US style, we do Euro style. So I'm happy to bridge the gap and get to some questions because there's a lot of good ones out there.
Yeah, no, I think that's great. And if all three of you want to put links in the chat box to, the stuff that you rep. That's great. I think there are some great general questions. And one that seems to keep coming up a bunch in the chat box is whether or not it makes sense to do triple pane in either hot climates or temperate climates. So if the three of you want to weigh in on that with your experience. I know actually that might be straight to you, Joe, with the two Northeast. Maybe you guys haven't done quite as many in warmer climates.
Well, I don't have a lot of experience in 1, 2, 3 climate zones. I haven't done any projects down there. What I will tell you is, I think Mike or someone in the chat, it's hard to track. Is generally speaking, triple pane in the far south is probably not going to be worth it. But you know, if you're really worried about getting into some of the details and the specs on that, I would recommend a building model of some kind, even if it's fairly rudimentary, even if you're just using different inputs on your manual J to size your mechanical equipment. Plug in a solar heat gain coefficient, plug in a U value, plug these things in, even if you're doing the simplest model. Something is better than nothing because there's so many scenarios, the orientation of the building, where the glazing is concentrated, all these different things. I mean, it's possible that a triple pane opens up a solar heat gain coefficient that somehow helps the performance of the building. It, you know, at the end of the day, the building is a system. And so you have to understand, you know, how the window is integrating with the wall, how the layout and the site design is influencing nature's impact on that building. So if you want to drill deeper, I would just really recommend trying to do some kind of even rudimentary modeling with a couple different scenarios on the build that you're looking at. But generally speaking, I would say triple pane is probably not necessary in those climates.
And we're kind of using, in this discussion on this topic, we're kind of using triple pane as a substitute for high U factor, right? So while that may be true that you don't need as high a U factor window in a southern climate, you know, the solar heat gain coefficient becomes super important, right? And getting that dialed in, because radiant heat, and Coda Ueno just wrote about this on GBA recently, how we think, you know, in hotter climates, because there's less delta T between indoors and outdoors, we have these lower requirements for R values. But basically what he was saying was, but that doesn't mean you shouldn't pay attention to radiant heat. You should pay more attention to radiant heat than in any other climate. So while maybe the high U factor isn't as important, I think that solar heat gain coefficient and just anything you can do to minimize radiant heat is going to be super important in a warm climate.
So Steve gave credit to Steve Bazek. Sorry, Steve, I cut you off, but I'll shut up quick. You gave credit to Steve Bazek earlier, and he would probably choke me the next time he saw me if I didn't bring up the fact that anybody who's trying to sell triple glazing based on energy efficiency is probably losing the war. And it really comes down to comfort. And it's easy for me to say that as a Vermonter. Sure, it's easy to picture yourself in front of that cold picture window sitting there in the wintertime with your girlfriend, but it's not going to, you know, that the same is true in the South. Who amongst us in this country can go 10 days without electricity and still be comfortable in their home? That's the question I ask. And if you're in the South, I don't know much about the South. I'm not even going to presume that I do for a moment, but I don't think I want to be in Arizona without electricity for 10 days and no air conditioning. And if I am, I really hope I'm in a really cold masonry, concrete, you know, adobe building that's got some pretty damn good passive strategies built in to stay cool.
Yeah, I was going to say, thanks for bringing up the triple pane being used all the time. It's one of the things I really don't like about, everyone talks about triple pane. Many North American triple panes, not the ones we're talking about here, but many of their best U values are 0.23 type, you know, and, you know, our double pane is a 0.18 generally. So a double pane will outperform a lot of the triple panes in North America. And Sierra Pacific and Alpine have high performing windows compared to what a lot of people are looking at it here.
So I want to shift over to another question because we've had this one's come up a lot, so I'd like to ask it. and that's about general environmental impact of windows, and looking at them from a global warming perspective. And have you guys put any research or time thought into the best windows simply from an embodied energy carbon perspective, looking at both materials and maybe shipping and those types of things?
I'm sorry, I gotta jump on that one like a grenade, guys. I apologize for dominating this one, but I'd probably be fired tomorrow morning if I didn't. So, as a representative of Sierra Pacific Windows, I'll tell you that Sierra Pacific Windows is a division of Sierra Pacific Industries. We're owned by the Emerson family. We are who is the second largest private landowner in the United States today. The Emerson family owns over 2 million acres of SFI certified, third-party certified forest lands throughout Northern California and Washington State. Embodied energy, carbon, these are all things that we eat, live, and breathe. And what I will tell you, hands down, without a doubt, and as you look over my shoulder and see a Douglas fir glulam curtain wall system, these are things that we focus on and prioritize heavily. How do we help architects meet the goals of encapsulating and sequestering carbon? How do we lock this up in buildings? Well, the answer is we use 3-inch wide glue lamps that are however deep long to build commercial window systems. We have other window products that are very heavy in the use of wood. Wood is by far the most sustainable resource in terms of a building material on Earth. It's the only thing that's renewable. If we're using aluminum, which we do, all of us do, when we're using aluminum, we have to accept the fact that there's going to be a negative consequence to that long term. That's not going to be recycled and be as pure quality aluminum as it once was. When we're using vinyl, Greenpeace put out a study not that many years ago that pretty much stated that I think 98% of the vinyl windows in this world are not recycled. So PVC is recyclable. However, there's a huge cost burden associated with it. And by and large, every PVC, not UPVC, I apologize, every PVC frame that is produced, at least in the US, ends up in a landfill with few exceptions. So when you start talking about embodied energy and that stuff, I think without a doubt wood rises to the top. However, it does come down to what your client's expectations are. And if, if you're looking purely from a performance standpoint, you may have to lose a point or two in U value to use wood, let's say. I don't want to say sacrifice to use wood. That's not a good way to put it. But if you're purely just trying to build the tightest envelope you can and get the best performance you can out of the building, your material choices are probably going to be different than if you're coming at the project with the goal of how do I sequester carbon and how do I pick the right materials to sequester carbon.
Yeah, I'll jump in for a second on the which is a slippery slope generally. I would agree wood is probably the most sustainable of materials, but then it tends to cost more on windows sometimes. So in Europe, which I look towards Europe a lot for how they do things, they've eliminated so many chemicals and things that we're still allowed to use in the US. They make unplasticized vinyl in basically zero waste factories there. It's very rugged. It works really well, and the price points are good. If you can afford wood, then you go to wood, and I think that's probably a better choice. And when it comes to transportation, if you look at moving materials around, putting them on a ship is the lowest embodied energy compared to, the next in line is putting it on a train, and then the next in line is a long haul truck that gets less than 4 miles per gallon. So a container ship still spews plenty out, but it's moving a lot at the same time. So the carbon footprint, more or less, on transportation from Europe to here, on the East Coast anyway, is not too bad. If you had to bring it from Europe and then ship it into the Midwest, you're going to have a much bigger footprint. So.
Yeah, I guess I'll just add, we try to, I don't have the technical knowledge to tell you like what the LCAs are on this stuff. Obviously, wood is a totally different class of material, given that it comes from the earth. I think there's a fundamental common sense there. versus something that's manufactured where you can just see like these industrial boilers and all these other things somewhere in the process are happening. I do think that durability makes a difference. Obviously, a window that is well installed, and I'm trying to lead into this next question that I see chat popping off about. If you have a window that has to be replaced in 5 to 10 years, it doesn't really matter if it's made out of hemp and leaves. It's still requiring this whole process of replacement and adaptation of the building every time you replace it. So, something I like about working with Alpine is that they're 500 miles away. Everything in the unit from the extruded frame happens in North America. The glass is made in Denver and shipped to us, but that's only works for our location. It'd be disingenuous for me to try to say that our window in some way outperforms or is built around the environmental impact, but certainly it's something we try to be sensitive to. So I guess I'm just kind of punting on this so we can move to this next question that at least 5 people have asked in the last 90 seconds.
Go for it, Joe. You got that.
I didn't even get a chance to read it. I have 27 chat notifications. So if somebody's been tracking it, please prompt me and I'll take a swing.
Yeah, I'll try to answer this question from Steve Basic about recycled content of UPVC windows. I don't have a good answer for that as how they do it over there. I know that they take their trimmings and everything and they push it back through the cycle in the factory. And yes, in Europe, they have put together processes to do recycling of PVC over there. The US is still not there. Maybe we'll get to it. That would be great. A PVC window from Europe is going to last minimum 50 years, I think. So hopefully we'll figure it out by then. But I certainly don't have all those answers.
The PVC window lasting 50 years, are you referring to every component? Because I do a ton of remodeling and stuff. We generally see failures at the seals and gaskets. So with that being the weak link, well, after the install, with that being the weak link, do you have a realistic performance expectation of the higher end window gaskets and seals?
Yeah, the gaskets are really nice, but they're also replaceable within any of these. So all the components are replaceable. The PVC holds up a long time. Again, that's going to come down to expertise and support, which is always going to be a tricky thing. You can replace parts on casement windows too, but people don't do it all the time.
Yeah, in my experience, homeowners almost never repair anything or maintain. They don't do the maintenance work that would really benefit them tremendously on the majority of the components in their home. I know Emily tells a great story about an ERV that was shut off. These things are, I think we almost have to idiot proof as many products as we can if we want to get the performance rating that we're promising when we sell these products and install them. Certainly I'm part of the problem. I'm installing stuff and probably not doing it as well as you guys would like, but I'm sure trying. If you guys provide a product that has gaskets that will last this client and the next client, I think you're doing a great job.
I think that brings up a good point, and maybe this is what didn't come up in the chat box, but what's the biggest failure part of a system? So like Travis, you said people don't, or first Steve, you said you could replace parts of casements, but the part of the casement that is often is like if the seal fails in the casement, the crank out is also usually not super great. And so it's like, we'll just take the whole thing out. Which parts of these windows fail? Like, could you take a whole section of a bottom double hung out and put a new sash in, and is it great? Or is the gaskets in the side and the operation, Brian and I talked about this earlier in the week as like, it would be great if you could replace parts or components of windows, because that would be a whole lot less expensive than replacing the whole window, which we all know never really pays for itself during the lifespan of the window. But if a UPVC window or, an aluminum treated exterior, what's the biggest failure on a lot of these windows that people are seeing?
Install.
Yeah.
Sorry. I know window manufacturers always spouting off about install, but quite honestly, the frame is the hardest part to replace. You cannot replace the frame without pulling it out. You can have damage to a sash. You can have damage and replace that, and it'll work just fine. If there's one thing I could ask everyone to do, it's just take a little bit more time and care into installing windows and doors. I cannot tell you how many times I've set foot on a job site and had somebody say to me, "You won't believe how fast we installed your window package." And every time I hear that, I just want to throw up on their shoes. It is not the answer that a window guy wants to hear when he sets foot on your job site. How fast you installed them does not tell me how good you installed them. Those are two different criteria. And I appreciate the fact that you may have bid this job hourly, but that is no excuse to hand a problem over to your homeowner and frankly to your window company. I don't know how many times, we're the ones that get the calls, and it baffles me that, I don't know why we haven't been able to, and I'm sure that Steve and Joe are probably inside jumping out of their skin right now because they probably have the same problem, but it comes back to expectations, setting proper expectations, teaching everybody involved exactly what's going on, how this is what needs to be done to be successful. And if you're not engaged on that level, you're asking for trouble.
I think the biggest thing we see is the quality of the team, right? So the install is part of that. And I think that's kind of what we're getting at, but it comes down to the architect having a window install detail. Like, what's supposed to actually happen? Are we just at the mercy of these guys out in the field making their own decisions about what should happen, with tying in the barriers and how it's set and taping and flashing and all this stuff? Or is that something that's been created on the front end as an expectation for the project that, the architect, the builder, the homeowner should be able to come out? I mean, I'm not advocating for this necessarily. I know it's problematic, but the homeowner should be able to look at a plan and understand that there's a plan for the window going in. They don't have to understand what that plan is, but they should be able to see here's how my window goes in. And you should have support from the window manufacturer in that, they should be receiving delivery or checking on a job site or making sure that those details are there. I think it's unfair to just put it on the installer. That does happen sometimes, but the installer is a team member who has to be put in a position to succeed. I'm a sports guy, so I use sports metaphors, but if the coach doesn't have a good plan or the organization doesn't have a team that's designed to compete in the competition that they're set up for, they're going to fail. So you have to have an architectural design team that includes the builder and the architect and any other the key manufacturers or installers. And I think that's an onus that's on us as manufacturers to be involved with that and to provide resources for that and hopefully to follow through on that. So while I agree that yes, install is a problem, I don't think installers are the only ones responsible for the install. And then the other thing that, just to kind of loop in a couple other things, I encourage anybody that's using any window, get your hands on them and use your own common sense. Look at the window and think about what's going to happen when water hits that window profile. Are there weep holes? Are there corrections? Is there a latch that actually pulls the sash, the operable sash, tight so that that gasket means something? You can put whatever kind of gasket you want in the window, but if it's not under pressure, it's not going to repel water. So I think there is, a planning component on the front end, but there's also a common sense component of hold the window, look at the window. I like what Jake Bruton does. Once that window's in, blast it with a hose for, I don't know how long he does it, longer than I would. But if there's going to be a leak, catch it right away while you can still fix it. Don't catch it in 10 years when somebody's got mold on the backside of their sheetrock,
I think because it's 6:30, we're going to, it's 6:30 Central. I'm going to kind of try and wrap this up. I know that Russell and Joe had a great chance to give some sort of, I would call them excellent thoughts, but sort of final thoughts wrap up. But we have a chance to hear from Steve one more time. Do you have sort of a final thoughts? You want to put a bow on it, Steve? Help us out.
I'm not good at wrapping bows, but I will touch on what Emily was mentioning about rebuilding older windows. And what you look at is once you start, if you pull an older window out, you realize there's a bunch of rot underneath it anyway in these older homes. So we need to build their new places better. we just need to build better. So stop the bleeding as far as any new construction. And still, there's so much bad construction happening. So fixing that would go a long ways to not having to replace things later.
Well, that's a pretty solid bow, Steve. I'll give you full credit for that. If everyone does their job the best of their ability, we solve 90% of these problems.
Yeah.
Product failures are almost never the reason something has failed, because the specifications in the factory and the performance of the teams there tend to be more closely monitored than field conditions. So
and I'll mention Steve Basic wrote in the chat. He goes to the first window install, get the team there, agree on what's going to happen. There's plenty of people out there that are not even flashing prep window openings. They're just dropping the window and then taping on the outside and just walking away. So it's not complicated if everybody shows up and agrees how it's going to be done, because it's usually the design team and the supplier and the general contractor, whatever, but it's the one person or two people on site with the tool belts on that actually do all the work. And they've never been included in the process. So it's good for everyone to get in there and agree on what's going to happen.
Often the best window is the one the crew that's going to install it knows how to install properly.
Yeah.
I know that we have a way to continue this discussion on GBA. Brian, can you explain that briefly, and we'll wrap it up? And I just want to throw my 2 cents in here that Joe, Russ, Steve, you guys are awesome. Thanks so much for an excellent show. Go ahead, Brian.
Yeah, thank you, everyone, and everyone who's in the chat too, because there's a lot of great information and conversations in there. So usually on Sunday morning, I take the video and I post it on GBA, and on GBA everything is on a page where you can comment and chat. So if you have more questions or more comments, things you'd like to share, head over there. Look for that on Sunday or early next week, and that's one of the ways we can continue the conversation.
Thank you, Brian. Emily, you have any parting thoughts?
Yeah, my only parting thought was, if you have questions that we didn't get to tonight, I mean, there's just so much information. We could talk about Windows for a month, I think, of BS and beer. And so there was just so much great information tonight. If your question didn't get answered, and if one of the three of them can't answer it, if we've got people who are on here who represent climate zones 1, 2, and 3, feel free to continue the discussion over there, because we're trying to expand, what works great for the Northeast doesn't work great for the Midwest, doesn't work great for the South. So we really want to continue this discussion, and we encourage both of our panelists to answer questions for people who didn't get their questions answered, but also for people who are not in the climate zones that we even talked about tonight to keep talking about it on GBA. So I think there's going to be a lot of continued discussion about this, and maybe we'll do a whole BS and beer on installation details. Ben Bogey and Jake, if you're out there, I'm just saying.
Get ready.
That's an excellent wrap up. Thanks so much for joining us tonight. And again, thanks to our
you,
panelists
everyone.
and guests.
Good night, everyone.
See you for part 2 of the window discussion. Good night.
Yeah.
Thanks.